So this is going to be a two-part screencast. In the first part, we'll build our base router for handling GET requests, and we'll extend it in the second video so that it handles POST requests as well. As you can see, I have my browser, my terminal, and my code editor stacked up on the screen. So let's start by creating a new file and we'll call it basicrouter.js. Now, like last time and as a standard practice, type out use strict within quotes on the first line of your file to enable strict mode, which also lets us use ECMAScript 6 features in Node.js at the time of this recording. The first thing we'll do is bring in the HTTP module as we did last time, because we want to instantiate a server instance which will bring in the requests from the outside world and allow us to serve responses as needed. I'm using the const keyword because we don't want to mutate or modify the HTTP identifier once it is locked in to use for the HTTP module. You could use a let as well for this purpose. And with ES6 in the house, avoid using the var keyword due to its non-adherence to block scope, which is a better and more manageable scope than the function level scope that var produces. Next, I'm going to use HTTP's createServer method, but this time, instead of writing an anonymous function inline, I'll refer to a named function called router, which we will create in a second. Once again, we are going to make this server listen in on port 3000. Now let's create our router function, and this will accept our familiar request and response arguments because this is the handler function for our server instance. Hence, the createServer method provides us with these input and output variables and their associated methods. So I'll follow this up with a replica of what we created in the Hello Node screencast. We are using our familiar write-head method on the response to dispatch a 200 OK and a content type header that signals my browser to expect HTML, and we are finishing our response by sending an h1 tag with the text hello router. Okay, let's test it. There, it works as expected. Now, the REQ or request object as well as the response object comes from Node's low-level implementation of the server instance. So you get access to all headers and are able to set them in the response as well. Now imagine that we have this route API/products that accepts product ID, color, and sort by parameters in the URL. The request object in this case, among several other things, provides us with these three properties. The req.url refers to the entire route URL after the hostname and the port, while the req.method points to the HTTP request method, which is GET in this case. Also, we have the req.headers property that delivers an object containing headers as received by the server. Shown here is an abridged list of the headers that are received. Keep a mental note of the req.url and req.method properties, as these will come in handy as we continue building our router instance. Let's use console.log to output request.url and request.method properties, and let's see what we get. Make sure you restart your app. Now when we access the default route, that is accessing localhost 3000 without any specific route paths defined, the req.url returns a single forward slash. The method is obviously get. Next, if we access forward slash about, that is what we'll get in the req.url property. Once again, accessing a route URL which includes URL parameters returns this. Now this last one is a case where you first want a separation between the route and the parameters that were sent along with the URL. This can be done by using regular expressions or regex in JavaScript to search and break down this string based on a pattern. Or we could simply use one of the many helper modules and their methods that ship along with Node. One such module is the URL module. So bring that in like so. Now inside the router function, we'll use let to declare a variable called base URI, and we'll use the URL module's parse method like so to process the request.url property. Parsing refers to processing a piece of data into a set of usable outcomes. In this case, let's console log out what the url.parse does by accessing the base URI variable. You can see here that the url.parse returns a JavaScript object that, among many other things which may or may not be present, gives us access to two very important parts: the path name, which is the route path itself, and an object containing key value pairs for our URL parameters, which can be accessed by the query property. Notice the true option that I've used here when invoking the url.parse method. This ensures that the query property returns a usable JavaScript object with the keys and values extracted from the URL parameters. If you do not use the true option, then you'll just get the part after and including the question mark from the URL as is, with no decoding or parsing done. This aspect of the url.parse method is very smart. Notice how when I have two URL parameters with the same keys and separated by ampersand, it clubs the values in an array under a unified key. This is incredibly useful and saves us the time to do the extraction and consolidation. Alright, now we need a way to store our routes and the corresponding handler functions that they should run. To do this, I'll create a simple JavaScript object called routes, inside of which I'll create two subobjects, one each for get and post like so. So at the top level in the routes object, we'll have a key called get with an object which will house all the get routes and handler functions, and we'll have a key called post which will house all post routes and handler functions. Since request.method returns an uppercase string, make sure you write get and post in uppercase as well. We will also make a route handler for times when a route does not exist in a routes object. We'll call this NA or not available, but you can name it anything you like. Since values and objects can be functions, we'll create a function which accepts a request and response, and will respond with a 404 header, which means not found, along with the text which says content not found. Now go into the get category, and I'll create my first route handler by setting the key as /, which, if you recall, is what we get when the default URL is accessed. For the / or the root route, we'll create an arrow function. And I forgot the fat arrows while declaring the not available route handler, so I'll just drop that in now. Now for the root route handler, I'll just copy and paste the res.writehead and res.end statements from the router function. We just want to display hello router when the root route is accessed. Let's get rid of the console.log now since it's not needed. Okay, now to access a route handler based on the route the user is trying to access, we'll first create a variable called resolveRoute, and for its value, start by accessing the routes variable and using the array notation, first attempt to access an element where the key is req.method, that is either get or post. This way, you first get your selection in the routes object to either the get or the post structures. Then, to get hold of the actual route handler itself, use another pair of square brackets and this time type in the base URI.pathname. Remember how the URL.parse returned an object containing a key called pathname? This key refers to the actual route minus any URL parameters that are separated by a question mark. This way, you're first accessing either the get or the post objects depending on the method of the request, and then accessing the exact route handler function. And this function is what is returned into the resolveRoute variable. Let's take a moment to revisit this concept. In this statement, when a request comes in, the first part of the square bracket notation will resolve to the request method since we are accessing the req.method property. This, for our purposes, is let's say either get or post. Once this resolves to either get or post, the second pair of square brackets will resolve like this. Ultimately, the resulting statement will directly be able to access the route such that in the end, the resolveRoute variable contains the exact route handler function that we want. Now, if we restart our app and try to access the route, it just hangs in there till it times out. Well, this is because we have not invoked this route yet. We've just resolved it from the routes object. Remember, the route handler is a function, so you need to invoke the function in order for the function to work. So now we'll use an if statement to first check if the resolveRoute is undefined or not. If a particular route is not found in our routes object, you'll get an undefined. So if the resolveRoute is not undefined, then that means a route handler is available, and since the route handler is a function, we'll invoke it and we'll pass in the request and response since those are required by the handler to work. And if a route handler is not found, then we'll access our not available route directly and invoke it by passing in the request and response objects like so. Now, if we restart the app, accessing this particular route throws a content not found since we do not have a handler for this particular route and thus the not available route is returned. If we access the root, then you can see our root route handler in action, which displays the message hello router in an h1 tag in the browser. Now in the get routes, let's add another route handler for the route path /about. This will also display an h1 tag with the text, this is the about page. Restart the app. And here's our root route. And if we access localhost on port 3000 /about, you can now see our about handler in action. Now, let's create a route handler for an imaginary API endpoint called getInfo. Now remember how URL query parameters are returned by the URL.parse method into a key called query? When we are invoking the resolved route handler function, we can extract these parameters and store them in our request object so that they can be used in the handler function easily. Otherwise, you'll have to use URL.parse again and again to extract these as an object. So right before we invoke the route handler, we'll access the request object followed by a key called query params like so. This is a custom element that we are creating here and storing into the request object. Remember, the request object returned by the createServer method is a JavaScript object, and we can insert any custom keys or methods into the same. So req.queryParams will either access the existing key if already present, or will create one, and we are setting this to base URI.query, which will return an object containing our query parameters if the route URL contains them. Now in our API/getInfo handler, I'll end the response and I'll dispatch a stringified version of the req.queryParams parameter. Now let's restart our script and let's access the about route first. This is working fine. Now I'll access /API/getInfo and I'll pass in two query parameters, prod and color like so, and you can see our object on the page as expected. So if you have a single page app like an AngularJS or a Backbone app, for instance, then this would be the kind of place where you would access a database like MySQL or MongoDB, fetch data based on the query parameters, and then return the results as a JSON object, which your single page app can easily consume. By the way, for sending a valid JSON, simply change the content type header to application/JSON, and there you go. Alright. That was quite a lot of work, and we have jumped straight into a rather complicated script. But follow along and you'll be all fine. In the next video, we'll handle post routes. Do watch this video a couple of times to get a hang of the process if it is not clear at the first instance. You can also download a completed version of this script from the downloads section with this video.